Hi. So here we are in our R&D center, Lasermet R&D center in Cebu, in the heart of the Philippines. And this is our demonstration laser lab. So we're going to go inside and take a look at the ICS-9 laser interlock control system. Let's go. So this is it, the ICS-9 system. Before we can use the system, we need to have the key. So your LSO can control access to the lasers and use of the lasers in the lab by controlling access to the key to the interlock system. So we put the key in, turn it on to the enable position, and what we can see now is indication that there's a couple of interlock inputs that are open. So what we're going to do is, first of all, we'll go over here and we'll close the door. So the door closed. Now we see that those lights have gone out, but we still have the other interlock input, which is open circuit. So we'll go over to over here we have the laser curtain. And we'll close the laser curtain. And come back here and we can see all the lights, the interlock input lights have gone out, so that means that all of the inputs are good. And we notice here that the arm button is illuminated blue, so the system is ready to arm. So if I press the arm button, then we get the system armed. Then we have the audio alert here, so that is announcing the status of the system, and that will announce the change of statuses as we go through. I mean, I appreciate that quite a lot of people might find that annoying and might not want it, so you don't necessarily have to have that. But the other thing is, if you do have it, whenever you have a change of state in the system, you can choose which changes of state that you want it to announce. So it doesn't have to announce everything. I mean, you'll hear it going on, but you don't necessarily have to have it, but you can have it, and you can have it specific to whatever you want it to announce, okay? So now that we've armed the system, the illuminated sign outside, which we'll see later, will have changed from the green state to the red state, so showing that the lasers are potentially in use in the lab. At the same time, we have here, the mag lock is now engaged. Okay, so that means that you cannot open the door. Okay, so the door is held closed. Now, the purpose of that mag lock being held closed like that is to avoid interruptions to your laser operations. Because we've got the interlock switch here, and this is detecting, and if you open the door, it would trip out the system, and that would render everything safe, and that's great. That's what we need, the basic function of a laser interlock system, to maintain safety in your laser lab. So if someone comes barging in, it trips out the laser, but obviously very annoying to the users if it keeps getting tripped out. You know, you've got the illuminated sign outside, but people may or may not see it. The illuminated sign is a administrative control. The interlock is the engineering control. Engineering controls, you know, are much more powerful than administrative controls, because people could miss the illuminated sign, but that's why we have the interlock. But it could be very annoying. So we have the mag lock, and that stops your experiment getting interrupted by somebody accidentally opening the door when they shouldn't. It also has another function, because it reduces demand on the safety system, and reducing the demand on the safety system actually increases the integrity of the safety system. So this is a high integrity system, performance level E to ISO 13849-1. So, okay, so we that's the door. So from a laser interlock system, there are three potential interfaces to a laser. Okay, so those three interfaces are the laser interlock connector operator. So this is what we have here. Basically, every laser has it's the universal interface, the laser interlock connector operator. Every laser must have on a connector on it, which when it's open circuit, the laser can't fire. So the laser interlock connector operator is the universal interface. But there's three possible interfaces, and that's one of them. Okay. The second possible interface is the laser beam shutter. So this is a laser beam shutter here, and you'll see there's a laser beam there, and obviously it's a low power one. But it's going into here and it's not coming out the other side because there's a beam shutter. And the beauty of the beam shutter is that it doesn't interrupt the actual laser itself. The third interface to a possible interface to a laser is the interlocked 110 or 230 volts, or it could even be three-phase. This is not used so often because it's not a lot of lasers. It's not something you want to do is interrupt the 110 volts or 230 volts. So, but it is a possible interface. So that's why we have it here. Now the ICS-9 has you can have 9 outputs. Here we've only got 5 connected just for demo purposes, but it could have 9. But it's actually configurable. I mean, it's expandable, so you could have as many as you want. Yeah, but 9 is standard. So the interlock connector. So interlock connector operator, we operate via these distribution boxes. Okay, so once the ICS-9 is armed, then we have the possibility to actually arm the individual interlock connectors or the individual lasers. So here, if we press this, again you get the announcement from the audio alert if you want it, and now this is armed, and that particular the laser that is connected to it can now be fired. Okay, we can disarm it and rearm it and so on. We have the beam shutter here, so we can operate the beam shutter. So you'll see when I open the beam shutter, you can see the laser beam there. Okay, so we can control the laser beam using the beam shutter like that. Okay. So, and then, or we can use our interlocked 110 volts and plug a laser into here. Okay. So those are the 3 types. Now, and so you could have multiple lasers here, and they're all interlocked to the same system. They've got the same safety function set up. So if one of the interlocks trips, all the lasers are rendered safe. Okay. Now, if you're running long experiments, you might want to be able to go out of the lab without interrupting your lasers. So we have the override possibility. Okay. So if we were going to go out from the inside, we assume that people on the inside are authorized to operate the override. Although we could have a secure override if we wanted to, but here we just got a push button override. So we press this. Once we press this, we'll have 5 seconds because it releases the mag lock for 5 seconds, and so 5 seconds to open the door and 15 seconds to close the door. So the override will operate for 15 seconds. Those are configurable to whatever you like. If you want the override to run longer, you can. If you want the mag lock to release for longer or shorter, you can. So we're going to press that. We're going to go outside. Okay. So we go outside, and we've managed to get outside within 15 seconds and close the door, and everything's still running, and you'll see the status of our illuminated sign up here. Okay. Now to go back in, we don't want just anybody operating the override, so we have a secure override system using our keypad here. Another sign here, keypad here. Okay. So we'll put the code in. Now we can go through. Now this time I'm just going to demonstrate that if we leave the door open for longer than 15 seconds, that the system's going to trip out, and then you'll see that the lasers, everything's tripped. So the system's tripped, the beam shutter's closed, So you've got no laser there. Okay, no laser beam. Laser beam's still there. This one, but okay. So yeah, everything's closed. So what? So we're just going to rearm the system. Here now we close the door. Rearm the system.
Master ICS armed.
So what I want to demonstrate now is that, with your mag lock, if in the event of emergency, you've got the possibility to get out quickly by pushing the mag lock release here. We call it a break glass. It's not glass and it doesn't break, but that releases the mag lock and trips the system out again when you open the door. So you can do that from inside or outside. So we have those break glasses. So we have to reset that, so it's resettable. And we're going to arm the system again over here. And there we go.
Master ICS armed.
System armed, mag lock engaged. And just to demonstrate, over here we have the emergency stop. So anytime somebody hits the emergency stop, system trips out and the safety function is maintained. I can just demonstrate that again here because I'm going to open the shutter, arm the system,
Master ICS armed.
open the shutter so you can see the laser beam here now. And I'm going to hit that emergency stop and you'll see the laser beam disappear as the shutter closes. Yeah, if you're able to focus on there. So I'm going to hit the shutter. Hit the emergency stop, and there you go. System trips out, the shutter closes, and everything, the safety function is maintained. So that's the ICS-9 laser interlock system. It's a high integrity safety system. Performance level E to ISO 13849-1, which is the highest level of safety integrity. Dual channel, potentially dual channel end-to-end, depending on how your laser is set up and everything and what the safety integrity of the actual laser is. But we've got dual channel shutters so we can go dual channel end-to-end performance level E. So and there's another video on the shutters that discusses that.